Hello, this is part three of integral tests. So we're going to continue on our integral tests. So 22 says we got to take the integral of x squared minus 2x minus 1 all over x minus 1 squared, x squared plus 1 dx. So look at this very carefully. Uh, could we simplify this any further? Can we simplify the numerator? No, right? You cannot factor it. What about the bottom? No, you cannot. Should we do U substitution? Um, I don't think so. I don't think, yeah, it won't work. What about integration, trigonometric substitution? No, I don't think there's any trig. So I think we're gonna use partial fraction. But if you do, make sure the degree on the bottom is bigger than the top. Okay. So what we have is, I think it works, right? Yeah, so we'll write it out as x squared. So is the degree on the bottom bigger than the top? Yes, because over here, this would be, if you don't have to file everything out, this would be x squared, and then you have an x squared times an x squared, that's an x fourth. And then on the top, you have an x squared. So it is bottom heavy. So we definitely could do partial fraction decomposition. And x minus 1 squared, that could be broken down as really x minus 1 times x minus 1. X squared plus 1, really that's just x squared plus 1 equals. And then we're going to break it down like this. See, x minus 1 is a linear. And then x minus 1 squared. The third term is x squared plus 1. Okay, the reason why I put an a here because the derivative of a linear line or derivative of x minus 1 is a, I mean 1. The same thing here, this is still technically a linear line, so the derivative of that is b. For here, the derivative of x squared plus 1, it's like a linear, it's not constant, it's like 2x plus 1. It's a linear line, so that's why I put a cx plus d. Okay, then what we're going to do is get rid of the fraction by multiply both sides by LCD. So if you recall, our LCD is basically this. So it's going to be x minus 1 squared times x squared plus 1. So I'm going to multiply both sides by x minus 1 squared, x squared plus 1. Okay, the left side, everything cancels. You're left with x squared minus 2x minus 1. The other side, let's see. So I'm going to multiply everything. So here, the x minus 1 cancels. So you're just left with a, and then and it's still left with an extra x minus 1. And then over here, what cancels the x minus 1 squared? So you're left with b, x squared plus 1. Over here, what cancels the x squared plus 1 cancels? So you're left with cx, put this in parentheses, cx plus d, and you're left with the x minus 1 squared. Okay. Yeah, you're gonna have to boil this out, unfortunately. So I'll do this one for you. So when you FOIL out x minus 1 times x squared plus 1, this is what you should get. You can pause it or you can try it on your own, but this is what I got. X cubed plus x minus x squared minus 1. And then over here, this is easy. It's already FOILed out, so just distribute that b. So that's going to be bx squared plus b. Yikes, this one is a big mess. So you would have to FOIL out x minus 1 squared, which is really, it's like x squared minus 2x plus 1. And then you got to FOIL out the cx plus d. And I'm going to do that for you. So it's going to be FOIL out. So this is going to be cx cubed minus 2cx squared cx. And then when you FOIL out this a, this is what you're going to get. So on the left, it's just x squared minus 2x minus 1. FOIL out this a, so this is going to be ax cubed. You know, it's a lot. It looks like one big mess. This is so basically, if you FOIL out this a, kind of collect like terms, this is what you get. So let's collect like terms. So the left is x squared minus 2x minus 1. And then over here, if you collect the x cubed, you have an x cubed here, x cubed there. It looks like you could factor, if you combine these, it's like ax cubed plus cx cubed. And yeah, so yeah, when you collect to go with the highest power, so like ax cubed plus cx cubed, you can factor out an x cubed. So it's going to be really a plus c x cubed plus, and then go to the next highest power. So square, you can box anything that has a square. We have this one, this one, this one, this one. When you do that, you can factor out an x squared, and you're left with negative a plus b minus 2c plus d x squared. And then the x's, so you have an ax, a cx, and a negative 2 dx. And yeah, so you get negative a plus b plus d. Okay, then what we would do next is um, line them up. So we don't, on the left side, there's no an x cubed, so you can just say 0 equals a plus c, right? There's no x cubed. And then the x squares, you have an x squared here, so it's going to be, you just use the coefficient. This has a coefficient of 1, so it's going to be 1 equals this whole thing. Okay, and then keep on going down the x's. So over here, these are your x's. It's going to be negative 2 equals a plus c minus 2d. And do we have a constant? No. So let's see here. Yeah, so what can we do? What could we do? We have 0 equals a plus c. We have 1 equals negative a plus b minus 2c plus d. And then we have negative 2 equals a plus c minus 2d. Well, I see that a plus c equals 0, and we have an a plus c here. So maybe we could replace that with 0. Maybe that'll give us our d. So that gives you negative 2 equals negative 2d. Solve for d, so we're going to divide this by negative 2. And I get d equals 1. Okay, will that help? Yes. Uh, oh, okay, then I think we'll have to do some kind of, let's see. We know that 1 equals negative a, so we know that 1 equals uh, 1 equals negative a plus b minus 2c plus d. And we know that d is 1, so it's going to be negative a plus b minus 2c, and our d is 1. So what I would do is like subtract 1. I get 0 equals negative a plus b minus 2c. And hold on, actually I messed up. Let's kind of create a system of equation. So we know that this right here, we have 1 equals, uh, so we know that 1 equals a plus b minus 2c plus 1. We also know that -1 equals to negative a plus b plus 1. We also know that 0 equals to a plus c. So we can say 1 equals negative a plus b minus 2c. And then we know that our d, so right here, we know our d is 1, so we could put plus 1. And then we also know that if we kind of like clean this up, this is going to be -1, that's going to be 0. Wait, no. We know that a plus c equals 0, and so then this is going to be 1 equals -2 minus 2c plus 1. And then this will now become -1 equals a plus b plus 1. And then you get -2 equals -a plus b. We also know that a plus c equals to 0. So, yeah. And then I think we could say that we could say 0 equals to a minus 1. And if we solve for a, this gives you 1, a equals 1. And then I think we can solve for, if we put it back here, we can solve for c. So it's 0 equals 1 plus c. And then subtract 1, I get c equals -1. We got c equals -1, we got a equals 1. Now what about b? So we could put it, I think we could put it right here. You have -1 equals -a plus b plus 1. And then my a value is 1, so it's going to be -a plus b plus 1 equals -1. And then -1 plus 1 is 0 plus b. So I got b equals -1. Okay, so I got b equals -1, c equals -1, and a equals 1. Okay, so that's our answer. Now we have a partial fraction decomposition. So we're going to set it up like this. We have a over x minus 1 dx plus the integration of b over x minus 1 squared dx plus the integration of cx plus d over x squared plus 1 of dx. Okay, if a was what, 1, it's going to be 1 over x minus 1 dx plus b was, we said was b was -1, so it's going to be -1 over x minus 1 squared dx. And then c was, what was our c? -1. So it's -1 x over x squared plus 1. Let's just break it into two parts because there's a cx and d. Plus, and then my d was 1. It's 1 over x squared plus 1 dx. Okay. Now we can integrate this. I think most likely we'll use u substitution. So from this one, the integration of 1 over x minus 1 dx, we'll definitely use u sub. And I will use u equals x minus 1 and du is 1 dx. So that's going to be the integration of 1 over u, and then you're going to replace 1 dx with du. Plus, over here, your u is going to be x minus 1, and then my du would be 1 dx. You have a negative here, we'll take that out. That's a constant, so it's negative 1, and then you can replace x minus 1 with u squared. And then 1 dx will be expressed with du. Okay, clean this up again. So over here, x squared plus 1, negative 1x, I think we'll have to do u substitution. We're going to use u equals x squared plus 1. And then my du is going to be 2x dx. Let's put this negative in front. So this is negative, and now this is going to be positive. Thing is, we have a 1x dx. We got to get rid of this too. So I'm going to multiply both sides by 1/2. 1/2 du. 2x times 1/2 is x dx. So you're going to get minus u, and then 1x dx can be expressed as 1/2 du. And then 1/2 is a constant, so put that in front. It's still 1. Okay, lastly, the next one is still u substitution. You're going to use u as x squared plus 1. And then my du is 2x dx. And because I only have a 1, no, we cannot use u substitution. Instead, if you look at it very carefully, you have 1 over x squared plus 1. That's a special one. That's a tan inverse, right? If it's in the form of this, 1 over x squared plus 1, you can, it's really arc tangent, or 1 over ab of tan inverse of ax over b. Okay, let's clean this up. So over here, what's the integration of 1 over u? It's the ln of u, or the ln of absolute value. Over here, what's the integration of 1 over u squared? Well, let me write that as a negative. That's u to the negative 2 du. And that's not hard, right? That's going to be negative 2 plus 1 is, negative 2 plus 1 is, excuse me, negative 2 plus 1 is negative 1 divided by negative 1. So that's going to be negative u to the negative 1 over negative 1. Over here, this is easy. This is what's the integration of negative 1/2 of 1 over u? That is going to be negative 1/2 ln of absolute value of u. And then the integration of this 1 over x squared plus 1, that's a special one. That's tan inverse of x. And plus d. So then you got to just clean it up a bit or replace your u. So your final answer is going to be ln of absolute value of u, which is really, for this one, it's absolute value of u, or u was x minus 1. And then over here, we have a negative and a negative, so we know that's going to be a positive. And then u to the negative 1 is really 1 over u. So it's going to be 1 over, our u was x minus 1. And then this is going to be minus 1/2 ln of u, and our u was, what's our u? X minus 1. I mean, not x minus 1, x squared plus 1. Plus tan inverse of x plus d. Because we don't have any boundaries, right? Oops. Okay, so that's our final answer. So just a little recap, what we did was we had to use partial fraction decomposition. And then we got rid of the fraction by multiplying both sides by the LCD, boil it out a bit, and then line them up, right? X squared goes with x squared, x1 goes with -2, the constant goes to -1. Somehow use what you know. We know that a plus c is 0, substitute that back in, do some kind of substitution, and you'll get your other letters. Then continue with partial fraction decomposition. Yeah, right? Replace your a with 1, replace your b with -1, replace your cx plus d. Use your integration rules, right? And then don't forget to add the plus d. Okay, so that was kind of longer, but that's okay. Okay, let's move on to 23. So 23, we have the integration of e to the negative x of cosine 2x dx. So look at the problem very carefully. What can we do? Can we do u substitution? I don't think so. If you use u equals 2x, that'll never work. If you use u as e to the negative x, that'll never work. We can't do u substitution. I notice more carefully that they're multiplying two things, e to the negative x times cosine of 2x dx. So that's a big clue. You'll do integration by parts. Or also known as ILATE. So what do you think our u and what do you think our dv is going to be? I think our u is going to be cosine of 2x. So our u is going to be cosine of 2x, and then our dv is the leftover. So our dv is going to be e to the negative x of dx, right? And then what is my du? Well, the derivative of cosine is negative sine. And then the derivative of 2x is 2, so you put that in front. And then you have a dx. So if our dv is e to the negative x dx, our v is going to be the integration of e to the negative x dx, right? And what is that? What's the integration of that? That we have to do u equals negative x, du is -1 dx, and then get rid of this negative. So the integration by parts is uv minus integration of v du. So my u is cosine of 2x. My v is negative e to the negative x minus the integration of v, which is negative e to the negative x. And then my du is -2 sine of 2x times it by dx. Okay. Over here, this is not too bad. You just put the you could put the negative e to the negative x in front. Oh, over here, this looks like a mess. Let's kind of clean this. Well, let's see. You have a negative and a negative, so that becomes a positive. And then let's put the 2 in front. So let's kind of rearrange it. We have 2e to the negative x of sine of 2x d of x, right? And then what will we do next? Ugh. Oh, don't forget you have a minus. Or you could put the 2 in front, because 2 is a constant, right? And it looks like we have to do integration by parts again. So I don't want to do that again, but you have to. So what do you think my u is going to be? My u is going to be sin of 2x. What do you think my du is going to be? 2 cosine of 2x. My dv is going to be e to the negative x. It's the leftover, e to the negative x. Or don't forget the dx, right? And then my v is going to be the integration of e to the negative x d of x. So this is still the same. Then you have a minus 2, and then you still have to do that integration by parts again, so it's going to be uv minus the integration of v du. Okay, so if you clean this up, this is going to be negative 2, and then my u is going to be sin of 2x, and my v is negative e to the negative x minus the integration of v du. So my v is, what's my v? What's the integration of e to the negative x is negative e to the negative x, right? So it's going to be negative e to the negative x, and then you have 2 cosine of 2x of d of x. So if I FOIL this out, a negative times a negative will be a positive, so it's going to be positive 2 e to the negative x. If sine of 2x over here, let's see, you have a negative, and then you have a 2. So let's, yeah, this will be, oh, and then you have this negative 2. So that's going to be, let's just, negative 4, and then it's going to be e to the negative x cosine of 2x dx. So clean it up a bit. So this is going to be negative e to the negative x of cosine of 2x plus 2e to the negative x sine of 2x minus 4. And then we know this is easy. That's going to be the integration of e to the negative x of cosine of 2x dx. So you have the same thing here. So what you could do is you have a repeat of e to the x, e to the negative x cosine 2x. So what you could do is you can move this negative 4, you can move this to the right. So I'm going to add this to the right. Okay, so this comes out as, so the left side is going to be still negative e to the negative x. And over here, this is gonna, you could take out, I believe you could take out a 5, right? Because this is a 4 and this is a 1, so that's gonna be 5. So that's a constant, so take it out. Okay. And then what I will do is get rid of this 5 by multiplying both sides by the reciprocal of 5, which is 1/5. So it's going to be, the left side is going to be 1/5 times negative e to the negative x cosine of 2x plus 2e to the negative x of sin of 2x equals the integration of e to the negative x of cosine of 2x dx. And then I guess you could put the plus e on the left side. Let's put this in front and then move this to the right. So we kind of like, you can do that because of some kind of commutative property. So you could say, let's put this in front. So it's going to be the integration of e to the negative x of cosine of 2x d of x equals 1/5 of negative e to the negative x cosine of 2x plus 2e to the negative x. Let's see. Okay, so this is your final answer. Okay, let's move on to 24. So 24, we have the integration of cosecant x of dx. So we're gonna have to use some kind of identity. I somehow want to make, yeah, I want a cosecant square x. And to do so, I can multiply top and bottom by cosecant x plus cotan x. So I'm going to use one of our Pythagorean identities. So I'm going to multiply cosecant x by cosecant x plus cotan of x over cosecant x plus cotan of x d of x. You'll see why I did that because now we'll use some kind of identity. So this does not change our problem at all because what is cosecant x plus cotan of x divided by cosecant x plus cotan of x? It's just 1, right? So if you FOIL this out, this is going to be cosecant x times cosecant of x is cosecant square of x. Cosecant x times cotan x is cosecant x cotan of x. And then this is going to be cosecant x plus cotan of x of d of x. So now we're going to use u substitution. So u is cosecant x plus cotan of x. And then my du is, what's the derivative of cosecant x? It's negative cosecant x cotan of x. And then what's the derivative of cotan x? Is negative cosecant square x. And then don't forget your dx. So do we have a, so if our u was u is cosecant x plus cotan of x, and our derivative is negative cosecant x minus negative cosecant x times cotan of x minus cosecant x. Uh, I have an extra. Yeah, I have, as you can see, this is a positive cosecant x, and then this is a positive. So I'm going to multiply both sides by negative. I'm going to multiply both sides by -1. That's negative du equals to positive cosecant x cotan of x plus cosecant square of x of d of x. That's much better because now you're going to get the integration, and then we said our u is cosecant x plus cotan x, so you can just replace that with u on the bottom. And then you can replace cosecant x cotan x plus cosecant square x of dx by negative du. So you have a negative here, that's like a invisible -1, so you can put that up front. And what is the integration of u? That's easy. It's the ln of u. And then you still have this minus. And then don't forget you have no boundary, so you do have to add a plus c. Last step is replace your u with. So replace my u with what? Cosecant x plus cotan of x. Okay, that's it. Okay, let's move on to 25. So we have the integration of sin fourth x times cosine 5 of x d of x. So we're dealing with trig, and if you look at it more carefully, we have 4, which is an even, and we have 5, which is an odd, right? So I'm going to use focus. So it just means odd cosine means u is sine. So yeah, wait, first we should use some, okay, so odd means u is sine, so maybe we can break down cosine 5 of x as using your Pythagorean identities. Right? So one of your Pythagorean identity is cosine square of x plus sine square of x equals 1. And then if you want to solve for cosine square x, you would have to subtract sine square of x. You have cosine square of x equals to 1 minus sine square of x. Okay, so we can rewrite this problem as sin of 4x and then replace. Let's rewrite cosine 5 of x as cosine square of x square times by an additional cosine of x, right? That doesn't change your problem. This still gives you cosine 5x. But we'll replace cosine square x with 1 minus sine square of x. And then you still have the square, and then times it by cosine of x of d of x. Okay, and then so they say that since odd is cosine, so it means u is sine. So we'll just let u equals regular sine of x. And then my du is going to be cosine of x of d of x. Okay, that's what we need. So it's going to be, if our u is sine of x, sine fourth of x will be sine u to the fourth. And then 1 minus sine square of x raised to the second power. It's going to be 1 minus, and then sine square of x is going to be u squared. Raise it to the second power, and then you can replace cosine of x dx with du. Okay. So what we'll do is FOIL it out now, clean it up. What's 1 minus u squared squared? That is going to be 1 minus 2u squared plus u to the fourth of du. And then you may FOIL out this u to the fourth. So this is going to be u to the fourth minus 2u to the sixth plus u to the eighth of du. And then what's the integration of u to the fourth? It's going to be 1/5 u to the 5 minus 2/7 u to the 7 plus 1/9 u to the ninth plus c. And then you just replace your u with sign. So your final answer could be 1/5 of sin of 5x minus 2/7 sin of 7x plus 1/9 of sin of 9x plus c. Okay. Let's move on. Okay, how much are we going to do? We are going to stop we're going to stop, I'm just trying to figure out, it's 31. Okay, let's move on to 26 then. Okay, 26, we have a trig with limits. So our lower boundary is 0 and our upper bound is pi thirds. And we have tan of 5th x times secant 6 x dx. So we're dealing with tan of secant, so we can use e suite, which basically means our tangent is your u. So we kind of let's rewrite this problem using some of our trig identities. So what do we know? We know based on our trig identities, sine square x plus cosine square x is 1. I don't think we'll use that one. I think we'll use this one, tan square of x plus 1 equals the secant square of x. Yes, I think we'll do that. So we're going to rewrite this problem as let's leave tan 5th x alone. And then we're going to replace secant 6. Let's rewrite secant square of x as secant fourth of x times secant square of x, right? And we know that secant square of x is tan square of x plus 1. So over here we have 4 of them, so we can just rewrite that as tan square of x plus 1 squared, right? Because we have 4 of them, times by secant square of x. Okay, so then we're going to do on, what is it, on e suite. That means our tangent is our u, so we'll say u equals tan of x. So it's going to be, I'm going to leave our boundaries blank for now because I'll change it in a minute, right? So this is going to be tan of 5 of x, and then you're going to replace, whoops, no. We said that our u was tan of x and our du was going to be secant square of x d of x, right? So our u is tan x, so that's just going to be u to the 5. And then you're going to replace tan square of x plus 1 with, if our u is tan x, so this is going to be u squared plus 1, and then square that, and then you have du. So this will be simplified as u to the 5. So kind of FOIL this out. U squared plus 1 is going to be u fourth plus 2u squared plus 1 of du. And then this is going to be, you clean this up, this is going to, if you FOIL this out, this is going to be u to the 9 plus t u7 plus u5 of du. Then what I'm going to do is change my boundary. So what was our boundary? It was originally 0 to pi 3. So I'm going to change it. So if x equals to 0, and we said that our u was tan of x, u is going to be tan of 0, which is 0. And if x equals pi over 3, u is going to be tan of pi over 3, which means that u equals square root of 3. So our lower boundary is 0, and our newer upper boundary is radical 3. So yeah, u to the 9 plus 2, u7 plus u to the 5, we can start taking the integral. So the integral of u to the 9 is 1/10 u10. The integration of 2u7 is 2/8 u to the 8th. The integration of u to the 5 is 1/6 u6. And we are going from our new boundaries 0 to radical 3. Okay. So if you kind of put that in, it's going to be 1/10 radical 3 raised to the 10. 2/8 can be reduced to 1/4. And that's going to be radical 3 to the 8th plus 1/6. Minus 0. And let's rewrite it using powers. Radical 3 is the same thing as 3 to the 1/2 raised to the 10 plus 1/4 3 to the 1/2 to the 8th plus 1/6. Radical 3 is the same thing as 3 to the 1/2 raised to the 6 minus 0. I get 1/10. 3 to the 1/2 raised to the 10. Remember, when you raise, you multiply. So 1/2 times 10 is 5. And then 3 to the 1/2 raised to the 8th is 3 to the 4th. Plus 1/6. And then, yeah, 3 to the 1/2 raised to the 6 is 3. Minus 0. And when you put it on the calculator, you should get 981 over 20, and I don't think it can be reduced. Okay, let's move on to 27. So we have the integration of 0 to pi 3 of sin cube of x times cosine of x dx. So we have an odd power and a radical cosine of x. So I think we're going to do OCUC. That means our U is cosine. So wait, 3 is an odd. We have a sine. So that means odd, so a sine, your U would be cosine. That's what this means. So I'm going to rewrite sine cube of x as sine square of x times sine of x times the square root of cosine of x. Dx. And then I'm going to say I'm going to set u equals to cosine of x. And then my du is negative sine of x at d of x. And I don't have this minus here, so I'm going to multiply both sides. Okay, then we can replace sine square of x as one of your trig Pythagorean identities, right? So that's going to be sine square of x equals 1 minus cosine square of x. And then you can replace sine square of x with 1 minus cosine square of x. And then you can replace your cosine square x with u. And then you can replace your sine x, this sine of x dx with negative du. Okay, and then you have a minus here. So you can put that in front. So it's going to be 1 minus u squared times square root of u du. And then this is going to be 1 minus u squared times square root of u can be written as a power u to the 1/2 of du. And then let's change our boundaries. It was originally 0 to pi over 3. So if x equals to 0, our u is going to be, we said our u was cosine of x. So it's cosine of 0 equals to 1. And that, yeah, cosine of 0 is 1. And then if x equals to pi over 2, our u is going to be cosine of pi over 2, which is 0. So our new boundary is 1 to 0, or 0 to 1. And then what we'll do is just FOIL this out. 1 times u to the 1/2 is u to the 1/2. Negative u squared times u to the 1/2 is negative u to the 5/2. And then you have a negative 1 here. Oh, Wait, I just realized if you look at our boundaries, if we plug in 0, our lower boundary, it gives you 1. I messed up. So this should be 1 here and then 0 here. Can you do that? You can't have you can't do that, right? You can't have the the top heavy, you can have the upper boundary and the lower boundary mixed together. So what you can do is you're gonna have to rewrite this problem, but then you're gonna have to add an extra minus, right? So you can switch, you could put the 0 on the bottom and 1 to the top, that's what we want. But if you do so, you're gonna have to add an extra minus. And we know that 2 negatives becomes a positive, so that's going to be plus 0 to 1. And then we can start taking the integration. So the integration of u to the 1/2 is 2/3 u to the 3/2. The integration of u to the 5/2 is negative 2/7 u to the 7/2. And then you just apply the upper and the lower. So this is going to be upper is 2/3 minus 2/7 minus, and then if you replace your u with 0, it's 0. So 2/3 minus 2/7 is, you need an LCD, so this is a 7. So the 3, you get 14/21 minus 6/21 equals 8/21. Okay. I guess we can stop here. We'll do the final part in another video. So we'll stop here at 28.